Okay, welcome to Newton's second law. Let's just get started here. Number one, Newton's second law states that more mass gives you less acceleration and more force gives you more acceleration. It's pretty self-evident, really, when you think about it. It's something most of our brains are good with. Alright, let's try the next one. I have a kilogram, that's a mass. I have an acceleration, and I'm looking for force. Here's my equation. So let's just try this here. My acceleration is 4.05 equals, and I'm looking for force, and I know the mass is 912. So I'm going to have to multiply both sides by 912. And we get force that's equal to 3693 newtons. Which, if we wanted to, we could just round to 3,690 if we wanted to be good about our significant figures, because we only have 3. Alright, trucks require larger engines than cars because it takes more force to get more mass to more mass. Can you tell us early in the morning I haven't had much coffee? Okay, let's keep going here. Alright, what do we know on number 4? We know the mass of the car, we know the force on the car, and we're asked to find how fast it accelerates. Again, I'm just going to solve this equation for acceleration. I'm going to put force on top. 4620 divided by 1400. And that's going to give me 3.3 meters per second. And this next one I screwed up, so we're just going to omit, because I told you what her mass was and I asked you what her mass was. You know, that wasn't the smartest thing I ever did. I mean, I guess we could just say, well, it's 97 kilograms. Duh. Alright, let's see what we got here. Alright, let's try this one instead. Alright, so I have a 4.4 kilogram shopper, that's mass. Here's acceleration, and how hard you push, that's the force. So let me use the equation. Acceleration goes up with force and down with mass. So I'm going to substitute the mass value with 4.4. I'm going to put the force up here. I'm going to substitute the acceleration value with 7.5, and what that's going to give me is the force equals 33 newtons. Now I have an empty airplane with a mass producing a force, and I'm looking for the acceleration. I'm going to use the same equation, but this time I'm looking for acceleration, so I'm going to say acceleration equals the force acting on the airplane, which is 9,600 newtons, divided by the mass of the airplane, which is 2,400 kilograms. And that gives me an acceleration that equals 4 meters per second. Now the airplane above is now loaded with passengers, and it's encountering friction. How fast does it accelerate now? So I have a new mass, and I have a new overall net force. So first thing I'm going to do is I'm going to say acceleration equals force over mass. Now what I'm going to do is, for the force value, it's going to be the 9,600 newtons that I had before minus 1,400 for friction. I'm going to divide that by the new mass, and what that's going to give me is 1.7 meters per second. Now when I subtract these two from each other, what I'm going to get is, well, I forget what I'm going to get. I didn't write it down, darn it. Okay, anyway, now we're going to number 8. So what we've got here is a car that has this mass, experiencing this force, and instead of asking you how fast it accelerates, I ask you how long it would take. Now remember, that is time. How long it would take equals time. And you notice time is not part of this equation. But don't you dare freak out. All you have to remember is that you've already learned about acceleration. Now if we look up at the top here, what we'll see is we're going to have to use this equation. Acceleration equals a change in velocity over time. You haven't forgot that one, have you? I hope not. So here we go. So first I'm going to use Newton's second law. And I'm going to say that the acceleration experienced by the vehicle is equal to the force acting on it, which is 3,512 newtons, divided by its mass, 1,400 kilograms. So that means the acceleration on the vehicle equals 2.5 meters per second per second. So now I'm going to take that and I'm going to say, well, acceleration equals the change in velocity over time. And here's my acceleration right here. So I'm going to put that right here. And here's the velocity it's going to achieve. I'll put that here. So what I'll have is 2.5 meters per second equals a change in velocity of 22 meters per second divided by time. Now I'm going to swap these two. And what that's going to tell me then is that time is going to equal 8.8 seconds. Okay. Alright, this next one's a bit tricky, so don't get mad at me and don't get mad at yourself if you have a little bit of difficulty with it. So the first thing we want to figure out is, let's see, how long does the runway have to be? So what we're really looking for here is distance, which means we have to use the equation d equals 1/2 at squared, which means we have to know a and t. And we don't know either yet. This isn't a 2-stick problem, this is a 3-stick problem. Let's get started. The first thing we're going to do is notice that we do know the mass and we do know the force, so we can find the acceleration. So acceleration equals force over mass. Thank you for that one, Isaac Newton. And then what we've got here is the force is 17,400 newtons divided by 3,200 kilograms. So what we find is the acceleration equals is 5.4 meters per second. Great. Now I know what the acceleration is. I'd like to find out what the distance is, but you know what? Acceleration alone isn't going to do that to me. I need another piece of information. Here it is. I know how fast it has to go to get in the air. So that's a velocity, and it's starting from rest, so that my delta V is 62. I have to use this equation next. I have to use the one that says acceleration is also equal to the change in velocity over time. So what I do now is I say the acceleration is 5.4, the change in velocity is 62, and I'm solving for time. So we do the old swaparooski here, and what we find then is that the time equals 11.48 seconds. And sorry, I'm being kind of sloppy with my significant figures. Okay, I should only have 2 here. Anyway, let's keep going here. And now finally we're ready to do it. In order to find out how far is distance, I have to use the equation d equals 1/2 at squared. I'm looking for the distance. It equals half the acceleration, which I now know is this. 5.4 is how fast it's accelerating. Put that in parentheses. Times the time it takes to accelerate, which I now know is right here, and I have to square it. 11.48 squared. So therefore, the distance of my runway needs to be 355.8 meters long. Whew! I wonder if you got that right. That took a bit. Okay, hopefully this side will be a little bit less involved than the other side. Alright, a rocket having a mass of this is pulled down by gravity this hard and pushed up by the thrust of its rocket engines that hard. So the first question is to find the net force. That means I have, since these force vectors are pointing in opposite directions, the thrust is pointing upwards, gravity is pulling downwards. What we're going to end up doing is saying 8,312 newtons minus 5,448 newtons gives me a net force of 2,864 newtons. 2,864 newtons in an upwards direction. Now I want to know how fast will the rocket accelerate. Well, I know the force acting on it, so if I want to know how fast it accelerates, I'm going to use Newton's second law. So I'm going to say the acceleration equals the amount of force divided by the mass. The amount of force, the net force is what I have to use, is 2,864 newtons divided by the mass of the rocket, which is 556 kilograms. And therefore the acceleration of the rocket is 5.15 meters per second. Now, what will its velocity be? So I need an equation that has velocity in it. You know what? I think that's going to be this one. Acceleration equals the change in velocity over time. And I want to know its velocity. So the acceleration I now know is 5.15 meters per second. I'm looking for the change in velocity after 31 seconds. I'm going to multiply these two values by each other. And what that's going to give me is a change in velocity that is equal to 159.6 meters per second. Again, my apologies for the lousy job I'm doing with significant figures. Why will the rocket's acceleration increase as the fuel supply decreases? And the answer here is that less mass equals more acceleration. You might notice this with bottle rockets when you shoot them. That's not move, that's more acceleration. Alright, and the force should remain the same. Alright, at terminal velocity, the force of, it doesn't matter which order I put it here, so we'll say the force of friction, which is pointing upward, equals the force of gravity, which is pointing downwards. So you stop accelerating. Now, since I didn't indicate direction here, it doesn't really matter which of these you put force. You can put gravity here and friction here. It doesn't really matter. Let's move along here. Alright, look at this fun ride. So, the person is spinning around this way. Whoa. And at this point here, we let go. So what's going to happen is they'll continue going the same speed in the same direction and end up at the freak show, which I hope they don't have anymore. I never went into one. I always thought they were kind of sad. But he's definitely not going to end up in the corn dogs like you might think. Alright, let's keep going then. I threw a baseball in outer space. When would it stop accelerating? As soon as it leaves your hand. In other words, as soon as you stop putting force on it, it's going to stop accelerating. When would it stop moving? Well, basically, never. Or until another force acts on it, which, let's face it, in outer space is going to be a long time. We're ignoring gravity here. Alright, number 4, use Newton's second law to explain why a bowling ball, which has a very large mass, and a paperclip, which has a very small mass, both accelerate at the same rate, even though the force of gravity on the bowling ball is much greater. Well, here's the idea here. I'm just going to do it using equations. Alright, so I'm going to let you write out the words, but basically here's the concept, okay? Because it's hard to write words with this stylus. So here I'm going to do the bowling ball has a huge force that's acting on a huge mass and producing 10 meters per second of acceleration. So that's Newton's second law, right? So what I have is acceleration equals force over mass. A huge force divided by a huge mass gives that bowling ball 10 meters per second of acceleration. Now let's look at the paperclip. Paperclip has a very tiny force acting on a very tiny mass. And so when I divide that tiny force by the tiny mass, I still get 10 meters per second because the force of gravity is directly related to the mass of the object involved. You can't, if you double this one, you'll double this one. If you quadruple this one, you quadruple this one. So it always equals 10. So find some way of writing that in words and we're good.